Hi, everybody. Welcome to another Couchbase webinar. Today, we are hoping to bring all of our developers into the fold. We have Matthew Groves, our DevRel engineer, back with us, and special guest from senior developer advocate Nitish Raghavanandanan, who I have practiced a couple times. Nitish. Thanks so much for joining us. Natisha's been on the back end in our engineering team, helping to develop a lot of our latest and greatest technology. So it's really awesome to have you here. Also doing some cross country stuff here with Matthew in Ohio, United States, and Nitish in Munich, Germany. So cool to have this conversation across a pond. Anyway, Couchbase, we've been working on a lot of great AI features within our products. We have Capella IQ, and we're going to talk a lot today, I think, about vector and vector search and show you a lot of really great demos and examples. Last month, if you missed it, we had a webinar called Let's Talk About AI, much more high level, but a really great presentation with Jeff Morris and Rahul Pradhan, talking about just industry-wise kind of the future of AI and why Couchbase has decided to, of course, join in and create some really great features that will enhance the AI experience, both if you're developing apps for AI or if you want to use AI to develop those apps. So I will now kick it off to Matthew. Thank you both for being here.
Thank you very much, Suzanne. And let me just get my screen going here so we can see what's going on. But thanks for joining us, everyone. We're going to go through some vector and LLM type stuff today. We have a lot of ground to cover, a lot of demos. So we're going to get into it here. This is our agenda for today. We're going to start by talking about just a quick introduction to AI and development. Why would I want to do it? What problems does it solve? What benefits can it give me? We're going to talk about vector search and vector embeddings, how those work, just the fundamentals of those. We'll talk about LangChain, how to use LangChain framework, and some demos of that. We'll do a RAG demo as well after that, and then we'll finish up with a hybrid search demo towards the end. And if you don't know what that is, I'll let you know more details about that. So let's get into it here. A quick introduction to AI and development. Some of you might have already know some of this ground, but it's always good to start here with a refresher. Just in case. So the AI landscape for developers, it's huge. We're not going to cover all of this today, not even a piece of it. But these are the building blocks, the type of components that LangChain supports. It's going to be a similar story in other AI frameworks, but we're covering LangChain today. So I figured let's start there. And there's a lot of pieces, just like any framework. So you don't have to know all of these to build something cool, though. So I just want to highlight a few, especially in the areas we're going to demo today. So LLMs get a lot of the attention, OpenAI and Palm and Llama 2, just to name a few, but there are many, many more. LangChain currently has 90 connectors, and then of course within each of those connectors, there's lots of different model choices to go from there. Document loaders, this is where you load in data that you want to index with vector search or something. So you can load it from Hugging Face or S3 or databases like Couchbase. Anywhere you have data you want to load or use with AI. And vector stores, this is where you put your vectors of your data so that you can do searches to find semantically relevant content. Pinecone is a well-known example here as specifically a vector database, but Couchbase can also store vectors, which we'll see today. And there's a bunch more vector stores like Annoy, for instance, is out there. And this doesn't even go into all the other categories like transformers, chat models, chat loaders, memory, etc. There's a lot of options and a lot of pieces. So some of the development challenges that AI can help us with and LLMs and vector search. One is semantic search. So because of ChatGPT, users expect a more meaningful search. As just a very simple example, if I search for dog, I expect Labrador in the results, even though those don't match text at all, but they have a similar meaning. And that's a really simple example just to make a point. Obviously, it's a lot more complex than that. depending on the model you're using. Content generation, for certain use cases, being able to summarize text, reword text, translate, generate code, generate images, generate audio. This is a tool that we've seen a lot of that being used for as well. That, of course, you can, if you want to, just delegate to ChatGPT. It gives okay answers sometimes, but we've seen how that can go wrong. ChatGPT has a cutoff date, which right now is April 2023, I think. So it's about a year old. And that'll get updated, of course, but it'll always be some period of time out of date. And it doesn't have access to anything that's not on the internet, right? So proprietary data, private data. How can we create a meaningful chat if we have all this data, but ChatGPT can't see them? And then, of course, one solution to that is you can train your own LLM, but that's very expensive, time-consuming, and it may not work out how you want to. So unless you're in the business of creating models, I'd say generally tend to avoid this option, but it is one option you can do. We're going to look at a more effective approach today called RAG, that you can use a well-known LLM plus your own data to get much better responses. So what can we do with AI to help solve these issues? So one is vector search. Vector search is not just for AI. You can use it to find nearest neighbors with any information that corresponds to a vector, which is just a list of numbers. RAG is another one. Nitish told me once that some people call this a hack. It is a kind of hack. It's a very good hack to use an LLM that someone else has trained, supplement it with your own relevant data on the fly. We'll see some examples of that today. And then finally, LangChain and Couchbase. So LangChain can help you load documents from a variety of sources, connect with all those different components. And Couchbase is a multi-purpose database from which you can collect and gather data from all over your enterprise and search it and store your vectors with your data. So I keep saying vectors. And again, some of you might already know what these are, but just a quick review on what vectors are and what vector embeddings are. So simply put, a vector is just a set of numbers, and it corresponds to data. And why would I want to do this? Because we can use this to locate other data based on those vectors that are nearby, right? So simple example here, I like to start with just a really simple two-dimensional vector, right? So this is a latitude, longitude for Paris. And so, we know where Paris is on an XY axis. So our model here is latitude, longitude, and our data is basically location of Paris. Let's add another dimension. So now we got a three-dimensional vector, and that's for red, green, blue. Now, of course, visualization, this is kind of starts to stretch the imagination to visualize a 3D graph of this. But our model here, again, is RGB. And we know based on the numbers that this is going to be light blue. We can find other numbers that are nearby, close to those colors. Then we get into LLMs. And AI models will generate a much higher dimensional vector. So I think it is, for OpenAI, it's 1,536 dimensions. And good luck visualizing that. I tried to in the bottom right there. Just a simplification, right? So this is a model that relates language to other bits of language, to put it simply. And so this, for example, this is a vector that corresponds to a description of Star Wars. And so we can find other movies with similar descriptions by using vectors to find ones that are close by. And that's via the nearest neighbor algorithm, sometimes called KNN, or K nearest neighbor. So if we have a bunch of vectors in a database and a vector generated from a user input, how do we find the most relevant data to their input? And that's nearest neighbor. That's what we do. So we just convert everything to vectors and find the ones that are close. So we'll go back to 2D space here, just to keep it simple. We have a collection of these vectors here. So I've got A, B, C, D, and E on the graph there. And if the user's input is which city am I closest to, it can grab the latitude, longitude from their phone, for instance, and give us that vector. Let's say it is 50, just to, again, keep things really simple. Visually, we can see that A is probably the closest neighbor, then maybe D, and so on. But we don't have to guess that. We can use the KNN algorithm to find the mathematically closest vectors to where we are on the map. And so again, let's expand this to 1,536 dimensions, and we can find semantically similar data based on user input. So storing a vector in your database, like this JSON example here in Couchbase, the flexibility of JSON to store and evolve values together is great for this and great for AI in general. But with vector search, this means you can now search your whole database for something that's close in meaning to a user's input. So as a user, I could type space battles with interesting characters and worlds being destroyed, and Star Wars might be the closest neighbor to that. And Star Trek The Wrath of Khan might be the second closest neighbor, and then the Terminator, and so on. But notice that in this case, the vector is right next to the data. This is not the only approach you can take. You could store your movie information in one database and your vector in another. But now, as we're going to talk about later, you need two databases and some way to sync them and integrate them, and it can be a bit of a hassle. LangChain can help a little bit, but it can't solve all the problems. But this approach here is what Couchbase is using. It treats vector search as a feature and not as a type of database. And that's the approach that Couchbase is taking. Although, if you really wanted to, you could use Couchbase as a standalone vector database if you really want to. I'm not going to discourage anybody from using Couchbase, but the approach here is that we have these two things together, stored together in the same document. So enough of this. I want to get on to what you've all come here for. This first demo is going to be a showcase of vector search using the Couchbase SDK. And so Nitish is going to share his screen, and then we're going to see a simple SDK vector search example in Python.
Yes, so I'm just waiting for the screen to come up. Yeah. Okay, so as Matthew, you mentioned like earlier, we have those movies that you could search by based on the semantics. So here I have got like a simple data set of like 1,000 movies from IMDb, which each of them have these fields like IMDb rating. You have like overview, which is basically the synopsis of the movie. Like for example, here you have a movie, Pirates of the Caribbean, and it has an overview which says like a short summary of the movie. And what we are trying to do is like just do a search based on this using a pure vector search. And as you can, I've built like a small demo here using like Streamlit, and essentially you can just search for things. So for example, like if you take the battles, so let's say movie involving intergalactic battles. Let's see what the results come up. Okay, so here you can see like some results. So Guardians of the Galaxy, yeah, here you can see, yeah, it's quite relevant. And then you have Star Wars, then you have like Star Trek, and you have District 9, and you have a French movie, I guess. So all these search results are basically based off like semantic similarity to what you search here. So in this case, it's intergalactic battles. And so this is just using like the Couchbase SDK. And I can actually show you the code as well. Yeah, so this is how the code looks like. Oops. So I hope it's readable. Yeah, so you have like a, like it is basically part of the full text search service in Couchbase, and you create like a search request, and then as part of it, you create like a vector query, and the vector query has like an embedding key, which is basically the field on which you are searching for. So in this case, it would be your like overview embeddings. And then you have the search embedding is your actual vector that you're searching for. So in this case, I'm generating it using OpenAI. And you have like how many closest neighbors that you want, or like how many documents that are close to your search query. And basically you do like the search, you also specify the index name, and you have your search request and how many results you want. And you basically process all these rows to get your result. And yeah, I mean, another thing that might be interesting for you is like, how did I get all this data in? Because if you look at this data set, this is the data set that I have. it doesn't have like any embeddings. And so basically what I did was for each of those rows, I generated the embedding using the same function that you already saw. So for each movie in this data set, I create like OpenAI embeddings and insert it into a new field called overview embedding, and then just inserted it to the Couchbase KB store. Yeah, that's kind of like a small demo of how to use like pure vector search using the Couchbase SDK. Yeah.
Excellent. Okay. You can hand me the screen back there, Nitish, and
Yes,
we'll go on to the next one. All right. So that was using the Couchbase SDK, which you certainly can do. And there's lots of reasons why you'd want to use just the SDK. But, just like any other type of development, there are frameworks that can help us do other interesting things and may, help do some of the heavy lifting for us. So one of the ones we want to talk about today is called LangChain. This is a popular open source framework. It's an abstraction layer for AI components. There are a few frameworks like this, but we'll just focus on LangChain today. It is AI-focused framework, and it can chain together interactions between components, hence the name. For each component, there's a common API, so you don't have to learn 10 different SDKs if you want to chain together 10 different interactions. And there's also something called LCEL, LangChain Expression Language, which we're not going to Nitish might show some today, I'm not sure exactly, but that can provide an even more concise syntax, kind of like SQL, but for your LangChain interactions. But basically, LangChain is the orchestrator in the middle of all those AI components. And then some of the advantages to LangChain, you can mix and match AI components. Just as a quick example of a potential stack there, you might be loading documents from S3 in your enterprise somewhere, and then processing them through OpenAI to get their embeddings, and then storing those vectors in Couchbase, for instance. That's just one example of the 3 different components that LangChain can connect to. You can combine LLM models if you want to use multiple models. Couchbase is one of the great things about vectors in Couchbase is you can have more than one vector per document. So if you want to index it on multiple models or index multiple fields, you can certainly do that. And then you can add memory to LLM models. So if you want to keep a history of the chat kind of going so that it can learn from the past interactions, you can use memory there as well. So that's the advantages of LangChain. And next demo, we're going to show that for some richer interactions. So, Couchbase SDK is fine if you just want to do a nearest neighbor search. But if you want to plug into the larger ecosystem, you might want to use that framework. So we're going to show LangChain in action, kind of the same movie search demo using LangChain, and then we'll kind of see the differences between them, compare and contrast.
Yes. Yeah, so I'll just use the same thing, same demo that we did earlier, except that here you can see there's a filter which says use LangChain. And so now I can just do the same search and we should get the same results as before. Yeah, as you can see, it's the same result as before. The only thing that changes is like how you do the search. I mean, we can also search for a different query string. So let's do a shipwreck survivor drama. So you get like a different film, like Lifeboat, Life of Pi, Usual Suspects, Jaws, and like a foreign movie again. Yeah, I mean, it can show you like how this whole thing works. Yeah, so if we go back to the code, so earlier we had this whole thing, this whole section of code that was doing the search. But now with the LangChain search, you would LangChain vector search, you just have a single call under which all these details are abstracted away. So you would have like your vector store. So in this case, the vector store is like you are just creating a vector store here where you provide like a Couchbase connection string, your bucket, scope, collection. You need to specify like what embedding model that you're using. So in this case, this would be like an OpenAI. And then you have your index and you have two fields, which is like your text key, which is in this case like overview, and your embedding key, which is your embeddings field. And yeah, so essentially if you have this interface where you can do like similarity search with score, there are like other things, like you can also do just similarity search without score. You can specify vectors and a lot more other things. So essentially you provide like the text. So in this case, this would be your search string, and it takes care of all the converting the text into embeddings and everything internally. And you have like the number of results that you want, and you can also specify some filters. So these filters are actually used for hybrid search, but we are not going into it right now. Yeah. So essentially all that you need for this is you need to have like your data in the Couchbase. So in this case, I'm using Couchbase Capella, and you need to create like your full text search index, which has support for the vector field. So I can also show you like the index that is used in this case. Yeah. Yeah, so it's basically I'm indexing like the IMDb rating overview, and like overview embedding here, you can see that it's like a vector field, and I'm using the similarity as like dot product, and like a few more things that I just used to show in the front end. Yeah.
Okay, excellent. Let's go back over here and show my screen again. So that was showing LangChain in action. Hopefully you can see there that it is going to save you some work, and you can also use that to plug in a variety of different components without having to rewrite the entire thing, right? So that's kind of the point of the framework there. Okay, let's move on to RAG. So I mentioned earlier that you could train your own model with your own proprietary data. That's one approach you could take. But of course, that is a very expensive, time-consuming process that you have to keep doing over and over again, and you could absolutely get it wrong. So if you want to, unless you're in the LLM business, you could use this approach instead, which is called RAG, or retrieval-augmented generation. First three letters of Nitish's last name, by the way. Total coincidence there. But anyway, so it is a fancy-sounding, complex term for something that's relatively simple, that's usually the way it works in computer sciences. We have to name something really fancy sounding before we start using it, giving it this buzzword. But basically, we're just saying the LLM is really good at generating language and understanding language and parsing it. But you are the one who's really good at collecting and storing useful, relevant information for your domain. So you both do what you're best at. Gather the most relevant information from your own data sources, your most up-to-date proprietary data sources, and send that off, that context with the question, to an LLM, where it will then analyze based on its model and the data you're sending to it and give you a much better answer. So the idea here is to reduce hallucinations and also provide answers that are more up-to-date. So that's a quick example. I want to walk you through kind of a flow of how this might work. So we're just going to talk about a chatbot for an auto parts supplier chain. You can imagine someone at AutoZone or Advanced Auto maybe sitting at their computer and they want to type in this question, or maybe it's someone going to the AutoZone website or whatever, they're typing in this question: how do I reduce muffler noise in my 67 Ford Bronco? And they could just go to ChatGPT directly, right? And that might give an okay answer, maybe not, depending on what ChatGPT has access to, but we can do better with RAG. So let's walk through that process here. So we're going to start with your data, which is JSON in Couchbase, maybe PDFs, or whatever else you have in your auto parts database, data lake, data warehouse, whatever. Okay, you take that data and you run it through an embedding model. You can go through chunks of that, and so everything is turned into vectors. And then that's then stored with the text and the vector in Couchbase. So it might be a chunk of text stored in Couchbase with the vector. And then you create, as Nitish just showed, an index that indexes the vector field. It can index other fields too, but we're talking about vector here. So it can index the vector fields and get those ready to query. All right, so that's kind of the front loading. That's the That's the initial work you have to do. Okay, the next part is a question comes in from whether it's the part salesman or customer or district manager, whoever. How do I reduce muffler noise in my 67 Ford Bronco? And so that question then gets run through the same embedding model. It has to be the same embedding model and turn into a vector. Okay, so once we have that, we can send that through a vector search in Couchbase here and say, give me the most relevant information that I have in my database for 67 Ford Bronco mufflers, reducing noise, whatever. And so it's going to return the nearest neighbors to that data, a bunch of relevant knowledge to specifically 67 Ford Broncos reducing muffler noise, and it's going to give me that information. I take that information then, and I package it up with the question, and then I send it to a LLM, which could be a different one from the embedding, by the way. It could be whatever model you want to send it to, because we're just sending text at this point over the wire, and then we get back a response with a improved answer. So this is more up to date, and it's using my proprietary information, but it's using what the LLM is really good at, which is parsing and generating English. And so that is how the whole RAG process works. So I want to turn it over now to Tish, who's going to show a RAG demo that's going to use Couchbase vector search with LangChain. And I believe he's created a chatbot that uses the Couchbase documentation. So you can ask questions to Couchbase docs. The relevant docs will be retrieved, and that will be augmented to LLM. So take it away, Nitish.
Yes. Yeah, I mean, we have this documentation, like you can chat with the documentation. So let's ask questions about, let's say, vector search. So let's say, what is vector search? How can I use it in Capella? Yeah, and so now you can see that it is generating like the answer. So what happens behind the scenes is like I've indexed basically all the documentation website of Couchbase into Capella. So like here you can see, let me just go to the docs. Yeah, so here you'll see like, yeah, it takes a few seconds before all the documents are fetched. Yeah, here you can see, for example, like documentation pages. So you have like texts that are from the documentation, like a Couchbase autonomous operator, or you have other things like .NET SDK and so on. So what happens under the hood is for each question, I'm generating like, I'm basically fetching the documents that are indexed already from the docs into Couchbase that are relevant to the search query, and then sending the results back off to OpenAI so that you get like a bit more coherent text. Because by default, this would just, if you just do like a vector search, you will just get like a bunch of documents that might not be like completely comprehensible. And so you just get this and then send it off to OpenAI, and then it basically generates coherent text from it. And you also get some links from it. So as you can see, this is like from the Couchbase docs. And you can also ask follow-up questions like, can you show some example code? Certainly, yeah. And so you get like some example on how to use it. Yeah. So this is actually using the Couchbase query, like the REST syntax for the search. And you also have like, again, like links to the documentation where you can follow along on how to use it. I mean, like going through the code for this is a bit more complex. So what I'll tell you is happening under the hood is like, for example, here, if you just see this question, it's not just the question that gives you the right response. So what happens is like you also have a memory here, which is being used. Due to this memory, this question is combined with the previous chat history to generate like the right context for your RAG application. And I mean, I'll try to see if we can find the, yeah. So this is basically a service from LangChain called LangSmith, which basically gives you observability. So you can see like all the questions that are being input and also all the different steps that are happening in the process. For example, here you have like the question that I asked, what is vector search? How can I use it in Capella? And you have like the whole documents that are fetched from the vector store. So in this case, Couchbase. And yeah, you have like different documents, and then you are basically sending all these documents to OpenAI. So if you look at it, yeah, so you have like all the documents that are part of your message that you send to Couchbase. I mean, not Couchbase, OpenAI, large like ChatGPT basically, and you get the result. And if you look at the next one, like this was a second message, and here you have like another call that is happening, which is basically summarizing the whole uh, chat history into a single message, because you always have like some limits to what you can send to all these large language models. Yeah, so this is like a kind of like a real world application that where you can ask questions uh, based on uh, some data that you have already indexed. Yeah, I also have like another demo that I can show you, which is like a bit more simpler, and which is basically this chatting with a PDF, which is also like you have the issue with all these large language models having a cutoff where things like the data is not quite up to date, like Matthew mentioned earlier. So in this case, I'm just uploading like a PDF. So I'm just using the documentation from the Couchbase vector store integration. So I've generated like a PDF out of it, and I'll just upload this document. Yeah. And if I upload it, it takes a few seconds. So what is happening behind the scenes is this whole PDF is getting converted into documents. Basically, it's a huge file, so the files is split into chunks of documents and then uploaded into Couchbase. So, like for example, here you would see the documents should be here. And in the meantime, we can just search for a question. How can I use Couchbase as a vector store in LangChain? And like you get like two answers. One is using the RAG approach, and another one which is just the pure LLM output. So yeah, here you get like the whole answer. Yeah, it tells you how to use it.
Of course, it's never fast enough when you're actually demoing to go through
Yeah.
the whole thing. But the thing I like most about this demo, Nitish, is that it shows the RAG results, and it also shows if you didn't use RAG, what's showing up right now, what your answer would be. And we're going to see, I think in this case, we're going to see that, yeah, it even mentions its own cutoff.
Yeah.
That the first answer gives you code, a full accurate description, and this one just kind of gives you, I don't really know, but here's some steps you might try, sort of thing. So this could be full of hallucinations or inaccuracies or outdated code, whereas the RAG result has much more up-to-date, usable results.
Yeah.
Nitish, one of the things, as this is loading, we got a question in the chat here. Could you talk about, you kind of mentioned this briefly, you talk about why the PDF needs to be divided into chunks in the first place, those 21 different.
Yeah, definitely. So like the thing with like, I mean, right now it's not getting that big of an issue because like with like the Gemini models, you have like a huge context window of like up to 1 million tokens. But like, especially with the earlier like large language models, you had like limited context. And that's one of the reasons why you split the documents into smaller chunks. And plus, it helps to have like more concentrated chunks for the LLM to generate like better answers. because otherwise you just have like huge volume of data and it's trying to go through the whole thing. Plus it's also cheaper and much faster.
And are there different ways to divide up the chunks? There's like multiple algorithms and methods to do that, right?
Yeah, like LangChain provides like a bunch of them, like including things like you can like basically summarize a document into a smaller chunk and then use it, like what we did with the earlier message history or like the chat history. Yeah. And I mean, like we can also go through like a small code like snippet, because this is basically all that is happening here. So you have like this prompt where you are like, so you are specifying like asking the bot to basically answer the question as truthfully as possible, and you provide like some context. So this context is basically the documents that you retrieve from your vector store. And as we mentioned earlier, like you have this LCL, LangChain expression language, where you provide like the retriever. So the retriever here you can see is like the vector store, and your question is basically coming from the user. You have your prompt. Like basically this is injected into the prompt and then sent to the LLM, and then you are basically formatting the whole thing. And
were you meant to show code, Nitish? We're not seeing any of that code on the screen here.
Oh, sorry. Let me share the right one. Sorry. Yeah. Oops. Mistake. Yeah. Okay. Sorry about that. So essentially, like the whole RAG approach is just this one line. So you have like a chain, which is, as mentioned like earlier, there's a LangChain expression language, and you provide like context in. So you essentially have like a prompt here, which is like this whole thing asking the bot LLM to answer as honestly as possible, and you provide like a context and the question, and these things are the context is basically coming from your vector store, all the documents that are relevant to the question, and then you have your all this thing is shipped off to the LLM, and your output is then just formatted. Yeah, so that's essentially how it works. Yeah.
Okay. Excellent. So yeah, we're getting some questions here. We will have time for Q&A, I think, at the end. So definitely marking these questions as ones we're going to get to. Let me bring the slides back up here, and we'll talk about the last thing on our agenda, which is hybrid search. So one of the things about the Couchbase approach to databases and data platforms in general is that, if you are in an environment or an enterprise or a team where applications and requirements continue to grow, things will start to look more and more like this, where we have a variety of different point solutions, a variety of different data management technologies, all for different areas and use cases. And creating and supporting all those data management technologies is costly for many reasons, right? So we're talking about license costs, but also patching and upgrades and learning the SDKs. And again, LangChain can help with that, but all the pipelines between these databases, copying data, syncing data, all those different things can be an issue. So Couchbase, we take an approach of having all these integrated capabilities that allows you to do all these different use cases with a single database. And this is helping to reduce something called data sprawl. Right, so you can see here on the screen, we've got a number of different use cases. We don't talk about all of these, right? We didn't talk about ACID transactions, but that's available in Couchbase. Caching is built into Couchbase. We talk about a lot of vector search, but certainly full text search is there as well. Geospatial search, some interesting things with graph traversal can be done. Real-time analytics, time series, mobile data, mobile syncing. This is all part of Couchbase platform. It can run on any of those clouds there. You can also manage it yourself if you want to be more hands-on with the cluster through Couchbase cluster. But I want to talk about something called hybrid search, which is specifically related to vector here. Is we want to combine vector search, and vector search is good. It can give us really good semantic matching. But there's other things that it still might make sense to use a more traditional predicate or filter. So this is a simple example right here. The search part, the and search, that is the vector search part of the query. But we still have, this is a SQL query in Couchbase, by the way, which has SQL for JSON data. But we have all those filters up there, like the and product size and product price and so on. Those are more traditional predicates to filter this down to shoes, shoe size, and so on. Where we could ask the vector search to give us information about a specific shoe size, but really that kind of filtering is much better off with a discrete match. And so you can bring in to the same SQL query, you could bring in those Couchbase features like time series and geospatial, ACID transactions, graph traversals, can all be done within a single query. So you have less need to stitch together data and queries from multiple data sources, right? So for instance, if you're using Pinecone as a vector database, Oracle as a SQL database, you have to first query Pinecone, take those results, use Oracle to filter them down, or vice versa. And this will be all code and pipelines that you'd have to write. Now, of course, we mentioned LangChain can help with that, but there's still latency involved in multiple servers, as well as managing those tools, patches, upgrade, complexity, all those sorts of things. So this is one approach you can take to kind of reduce your cost, reduce your complexity, is a hybrid search. So this is our last demo of the day. We're going to show a hybrid search. And this is going to include, I think it's going to include searching for movies by text that's close in meaning to the movie synopsis. And we're going to add a year range on there with a non-vector predicate to kind of show both filtering in action. So take it away, Nitish.
Yeah. I mean, to start with, like, I can show you like what you just showed earlier in action. So you can see like this is using like vector search as part of your SQL++ query. So you have like all the usual SQL++ constructs, like you can search for IMDb rating greater than 8, for example, and then you are searching for release year, like release this century. And you have your normal search, which is your full text search. And here I'm basically searching, in this case, for my vector field. So overview embedding, and you have like the KNN, and you are essentially putting the whole 1536 dimension vector. And yeah, at the end you say you want to get like the 5 nearest documents to this, and you're also limiting the whole query to 5. And if I click on run, it takes a few seconds, but then you get like the result. And this is essentially using the same underlying index and everything. It's just like a different way to use SQL++ to improve your full text search or like vector search results. Yeah. So here you get like some answers. Yeah. So here you get like some movies like Sal Nui Chuk, like 12 Years a Slave, yeah, Chak De India, like Green Book, and so on. I mean, here you can see like that all of them, they respect all the filters that we applied. So for example, our filter was like IMDb rating greater than 8 and released between 2000 and 2024. So this is 2018, this is 2020, and like, yeah, this is 2013, again 8.1. Yeah. So you can see that like all the constraints that we placed here, they are being like actually enforced. Yeah. And like I have the same thing like in this earlier demo as well, like where we can use like filters on top of your normal like vector search. I mean, because like it's pretty hard to like basically copy and create all these vectors for in the SQL workbench. So I'm just using this app because it's so much easier. And like here you can do like a filter, and like we can just apply the same filter that we did before. So 2000 to 2024, and like let's say IMDb rating 7. And like here you can see the filter that is being created. So it's like a conjunction query where you have like the released year should be between 2000
Natish,
and
would you mind zooming in a little bit on that text? A
yeah,
little further right
sure.
there. Thank you.
Yeah. So you can see like the uh, conjunction query where you are searching based on the released year between 2000 and 2024, and your IMDb rating has to be at least 7. Yeah. And like if you click on the search, now your results are getting like a bit altered, like compared to before. And this is mostly because like the scores get affected based on your filters that you apply. So 2000 to 2024. I mean, here you can see an interesting case that the released year here doesn't really quite match our filter, whereas in the SQL++ case, all these filters were matching. I mean, this is because like the way we do the hybrid searches, you get like a score for your vector part of the query. So like the semantic similarity. So basically the how close this text is to your synopsis. And then on top of that, you add the score that you get for like all your query filters. And these are basically summed up. So you could technically have something that is more semantically relevant than matching your filter, in which case you get like results that are still right from a semantic perspective, but might not be the best in terms of your filters. But this can be resolved if you know like this thing is happening. You can basically boost your the importance of your filters to avoid these scenarios. Yeah, I mean, so
Yeah.
you
So what you
essentially,
kind of showed here actually is two different approaches to a hybrid search. So one of them
yeah,
uses the SQL predicates for exact matching, and this one uses those conjunctions in the FTS engine that
yeah,
might result in a higher score, but not like an exact match there.
yeah, that's right.
Excellent, excellent.
And you can do the basically the same thing using like the SDK as well, like instead of uh, yeah, I mean the same all the examples that we showed, like you can use it via like the SDK as well. And like I mean if you want to see the code, like it's essentially uh, I mean it is similar to the earlier code except that you have like a search filter. Oops, which I'm basically creating like this filter within like the code, and this is basically supplied to as a parameter to your uh, search. And yeah, I mean, there's also one other thing which I can show you, which is like if you want to do like a search that is like on the title, you can also add that to the filter. And let's say IMDb rating, oops, not 77. And you can search. So now you should get like Star Wars movies alone. Yeah. So this is so essentially you can combine like your semantic search with all the other filters, like not just these filters, you have like numerous other ones like geospatial queries and all those things. Yeah.
So title search, that was using like a more of a traditional text matching system, right?
Yeah, it's actually using both. So in this case, this
Oh,
is searched against the like synopsis as well as your uh, title field. So here you would
right.
see, so it's matching the phrase in the series title. So it's
Got it. And
doing
it's
it
also
both.
applying that to the description with vectors as
Yeah,
well. Okay,
yeah,
great. Yeah, I could definitely see this being useful in like a e-commerce situation where I want to filter certain products down that I'm interested in buying, or any scenario like that where there's a large catalog of information or data, and I just need different ways to slice and dice that to find stuff that's most relevant to me. So
yeah.
vector is just the latest way to do semantic matching. There's plenty of other searches and facets that can be applied as well. All right. So we got some questions that have come in, but I want to just throw this list of links up here first. So some things you can check out. You can certainly sign up for Couchbase Capella. Natish showed that one in action there. It's a free trial right now. It's 30 days, no credit card needed for that. You can sign up and check that out. All the demos, all the source code for that's all available here on GitHub. Thank you very much, Natish, for posting those. So leave that for a second for you all to take a screenshot. And I believe that Suzanne will have some links for you as well in the email follow-up. And finally, we didn't mention this very much during the presentation. We didn't really have time, but Couchbase is also available on mobile devices with Couchbase Lite and the Couchbase mobile stack. Lots of great stuff that Couchbase Mobile can do. But one of the things that we're kind of on the cutting edge on with Couchbase and vector search is a vector search available on your mobile database as well. So if you're interested in that, some really interesting use cases for that as well. You can check out the link there to learn more about that if you're a mobile developer. So we're going to do some QA, but I want to show this last slide here first. If you want to contact us, specifically me or Nitish, happy to engage with you on LinkedIn or X or email. But let's just see what kind of questions we have coming in. We'll kind of start here at the top with the ones that are the most votes. Work our way down. Does that sound okay, Nitish?
Yep.
Okay. So first question here is, how good is this database, I assume Couchbase, querying CSV files containing multiple fields like number and date? So Couchbase is a JSON database, not a CSV database. However, there are at least one command line tool that ships with Couchbase to import data from CSV into Couchbase. And from that point, you can query it with SQL, with the full text search, vector search, key value lookup, all the stuff we've shown today. Anything to add to that, Nitish?
Nope. You summed up it quite well.
Okay. All right. Next one this is from our LinkedIn feed, actually. Based on your experience, Nitish, does summarizing the history of a conversation make sense in a conversation scenario where fewer tokens are used versus accessing the full history, which would consume more resources? Do you have any thoughts on that?
Yes, definitely. So I would say in my experiments, like I've seen that summarizing is a much better approach than like sending the whole chat history to these large language models. I mean, not only from the cost perspective, it's also like there's a huge context, so it takes like more time to process it. And so like summarization, it's again like an LLM call, and it basically, I mean, the summary is quite good. Like it's not like it's losing some of the context based on the whole history. And this definitely, like, the context size limit, you will hit it like if you have like a huge chat context. Like for example, if you have like 10 messages, it easily adds up, and you see the like the error from like OpenAI or like all these large language models saying that your context has exceeded. But I mean, even there was like some study where someone was comparing like these newer models with like 1 million tokens context size. I mean, even in those cases, it was said that like it's it's still, the answers are much better if you can reduce the context using like RAG approach. Because if you take such a case, if you have 1 million context, you could just as easily not avoid like the RAG approach entirely and just chat or like ask questions on like a huge dump of the data. I mean, it was still like, I mean, based on whatever I've read, there is consensus is that it's better to use uh, like summarization or reduce the context size for these large language models.
All right. And speaking of context, the next question is about context size. So is there an upper limit to the number of documents loadable into, he's calling it a RAG function. Is it limited to the total context window? So I think this depends on the LLM, right, Nitish? But
Yeah.
what are your thoughts on that?
Yeah, as you rightly said, it depends on the context with like limits of the LLM. I mean, earlier the approach was you just put like whatever you can into the basically the context for the question. But over time, it's also hard to find like diverse documents from your context that improve like the LLM. Because normally what happens is you have like 10 different documents that are kind of similar or like that have some overlap, and then you end up with not having much additional value. So yeah, I mean, in theory, you can basically chunk as many documents as you can up to the limit of the LLM. But in practice, you want to have like diverse documents that add value to the LLM to provide a different perspective to the answer.
Sometimes less is more, I think is what you're kind of
Yeah.
trying to say.
Yeah.
All right. Next question. Does it support role-based access control, ensuring the model only returns data that users entitled to access? So I'm not sure what the "it" is in this question. If we're talking about Couchbase, certainly Couchbase has role-based access control. You can restrict read and write access to, I think, down to the collection level at Couchbase at this point, all the way up to the bucket level if you need to. I don't know about how LangChain would interact with that kind of thing. Nitish, any comments on role-based, access control when it comes to LangChain or any sort of the SDK level things?
Yeah, I mean, so right now this will have to be done at the application level. So basically, like it has to come one layer above. So if you use like the whole rack chain with a user with a different permission level, then you get like the same RBAC from the Couchbase that is supported by LangChain. So essentially, you would need to have like some kind of mapping between the user and their access control, and then based on that, you need to use a different connection to the underlying Couchbase.
Okay. This one's a very interesting question. I don't know if there is a answer or not, but I just lost it. Where did it go? Okay, the question was, this is a question from LinkedIn feed. I want to develop a chat app that will display specific components depending on what the user chats. So for example, how do I bake cookies? That would result in a component like recipe of cookie DB entry being called. So what strategy would I use for that? Would it be embeddings or function calling or something else? Do you have any ideas on how this might be approached, Nitish?
I mean, I can take a stab at it, definitely. So, I mean, the function calling, from what I understand, it's similar to like the agents. So you have like you basically provide like the large language model, like a bunch of tools that it could use to answer your question. And this could be like definitely some direction that you can do. So in this case, you would have to write some methods that, or like some functionality that basically displays those specific components, and you could leave it to the like large language model to determine like how to call them. But yeah, I mean, this would basically, if you want to, I mean, this is something you can try, but would need a bit of fine tuning of the requirements and like yeah, the results to see if it completely makes sense. Yeah.
I like the way he's going with this application because it kind of takes it kind of elevates it to more than just question and response chats. Like this becomes more of a, like we've been talking about, adaptive applications, and I think that's the direction that Jared from LinkedIn is going here. So I would be very interested to see the results of that, how reliable we can build kind of our responses to then engage other agents. So pretty cool stuff there. Another question, kind of a broad one. How is security handled for Couchbase when retrieving data? So there's lots of documentation about that, but I mean, it's kind of the standard stuff. We talked about role-based access control already, but certainly TLS, SSH, all the standard stuff is going on there. When you're retrieving data and it's going over the wire, it's going to be encrypted, that sort of thing. So not sure how much else we could really comment on that. If you have a specific question, just throw it up there and we'll get into that. I think I maybe had one more question. Nope, maybe not. That's just upper limit on RAG functions there. So maybe we can get Suzanne to come back on here and make sure we covered everything.
Hey, all.
Questions?
Hey there. Hey, thanks everybody. I think this was a super informative session. I feel like we're going to have part 2, part 3, part 4 of this as we keep going. Anyway, thank you so much, Nitish. Thank you for staying up late. I know you're going to go out and have a beer now. Matthew, sorry, still middle of your day, more work to come. But I just, in the docs section, hopefully you got a screenshot of what Matthew provided. But there is also a link to today's presentation. I put the GitHub repo up there. Thank you, Dennis Rosa, for putting that up in the chat. And then if you'd like to hear our first session, the Let's Talk About AI with Rahul and Jeff from the Couchbase team, talking about IQ, vector, and what's to come. I put that in the on-demand as well if you want to review that. But thank you so much for today's session, everybody. I really appreciate all of the questions and hope to see you at another webinar very soon. Take care.
Thanks, everyone.
Thanks.